So let's start by setting some goals. First, I'd like to make sure that I can build gRPC-Haskell using their default build environment, which requires installing system dependencies with Nix. This setup was brittle before, so I wanted to sanity check that it works on this VM before proceeding to migrate it to Bazel. If possible, I'd like to automatically generate build files using Gazelle. Gazelle doesn't always produce great results, but it can be a useful starting point. Let's turn this into a checklist. The gRPC-Haskell repo relies on gRPC as a system library. I suspect this might be a source of trouble when we need to make that dependency explicit in the build system. Before, I wasn't able to build tests or benchmarks with gRPC-Haskell's Nix-based build system, so it might be too much to ask to have them build in Bazel, but at least I'd like to see if they do. The Nix build does work, but I edited that part out. And now let's see if we can build rules Haskell itself. I guess it would help to first have Bazel installed. I'll use Basilisk, which will take care of downloading and installing the right Bazel version. Okay, so things look promising so far. But ultimately we get a failure. It seems it can't find Java. I'll try installing it. It likes my Java installation, but now I'm getting a fatal GCC error. Something about fseek and zlib. I'm not sure what's going on. I'll try building from the rules Haskell demo as described in their GitHub README. The start script won't work with Basilisk, because then Bazel is a shell alias and won't be found by the scripts. I should have just sourced the script, but I opted to just remove the section that looks for Bazel. The build fails with an error about generate Cabal paths module. I'm not sure what that is, but it sounds like rules Haskell wants to call Cabal and wrap the call in a script. It seems to be using Python to do that. As we've seen on this show, the purpose of using Starlark instead of Python for Bazel is that Starlark isn't Turing complete, so the behavior of the build system is more understandable. There are times when code needs to call out to Python as a last resort, but rules Haskell seems to do it intentionally as part of its design. In particular, this seems to be a failure to find a Python module. Python's module system is notoriously finicky, so I'm already feeling a bit of trepidation about this design choice. We'll see how it plays out. I see some related bugs on GitHub, but nothing that points to a clear solution. To me anyway, as a non-Haskell person. I don't see a clear cause of this bug, so I decided to try to ignore it. It could be that Bazel is trying to build a misconfigured target that isn't supposed to build on my platform, or it could be that it's failing on some target that isn't exercised by automated tests, so nobody really noticed when it stopped working. I've seen both things happen before. I decide that Nix might be the issue. This is perhaps a bit rash, however it's not entirely out of line. The CI system for rules Haskell uses Ubuntu, and I'm on Debian. That could be an issue, but they're similar enough that I would expect them to work similarly. If the CI is working, I would expect everything to build on my machine as well, perhaps modulo downloading another dependency or two. The CI system also uses Nix, which I'm not using. And I found that in the past, that supplying the system with Nix tends to hide parts of the build configuration that are broken. And so this is really just me deciding that I'm going to chalk up this failure to a brittle configuration, possibly aggravated by Nix, and to direct my attention elsewhere. Since I couldn't get rules Haskell to build itself, let's try seeing if it can build a simple Hello World Haskell project. I have to look up how to create a simple project. Now we have a bare bones Cabal project. Let's check that it builds and runs. So far so good. Now let's try building and running with rules Haskell. First we need to set up Gazelle based on the Google Gazelle repo. All the repository metadata goes into the workspace file. Bazel is moving away from workspace toward a system they call Bazel mod. But since I'm already running into so much trouble, I'll stick with the older and more stable route. Now let's set up rules Haskell in the workspace file. I'll use the latest release of rules Haskell. Now let's try setting up Gazelle Cabal. And try to run Gazelle. I also need to add rules CC, since those are no longer built into Bazel. Now I need some repo called rules.sh. Here it is, shell rules for Bazel. I'm not really sure why you would want this. Most everything should be done in Starlark, and only shelling out to call things like the compiler and linker. This is a little concerning to me, suggesting that maybe they intend to do a lot of work outside the Bazel sandbox. I guess I also need Python rules, although I'm not really sure why. And I need to configure a Haskell toolchain. It looks like it's going to try to download GHC for me. I guess that's okay, but it would be best if they allowed me to point to a specific GHC on my system or download GHC from a URL I control. A common pattern is to commit the compiler to the source control repo, or to have it available from the package manager. If it's only accessible inside the Bazel sandbox, then some things become a lot harder, and I'm not sure where the benefit is. I'm not finding GHC, so let's try choosing another version number. Okay, it seems to like that version. Apparently I also need protobuf. I'm not sure why. This is a simple Hello World Cabal project, nothing at all to do with protos. Maybe protobufs are used internally for rules Haskell or something. Uh-oh, we're back on this generate Cabal paths module error. The file seems to be there, and Python seems to be configured properly, so it's unclear what's actually causing this error. Here's the CI config. You can see that they use Nix. On a wild lark, I decided to try building rules Haskell at head instead of using the latest release. Now that Gazelle runs, let's see if we can build the Hello World repo using the build file it generated. Nope. Let's try adding stackage base as a dependency. It works! Hello world!